Hello, everyone. This is question number 4 on motion at constant acceleration. So here we have a stone that is thrown vertically upward with a speed of 4.5 meters per second at the edge of a cliff that is 55 meters high. We're looking for how much later does it reach the bottom of the cliff, and what is the speed just before hitting. So as usual, the first thing I'm going to do is draw a picture to get a sense of what's going on. So here's the person standing there. They're throwing it upward with an initial velocity of 14.5 meters per second, and the cliff height from where the person is all the way to the bottom is 55 meters. So the first question is, how much later does it get to the bottom of the cliff? Well, if we just kind of, again, number of different ways to go about solving it, trying to do it in one stop. What I have here is the delta y, which is the vertical displacement now, is simply equal to the initial velocity multiplied by time plus 1/2 times the acceleration times time squared. So I can just plug the numbers in. Now, again, the trick in this is making sure that my positives and negatives, every number can't be positive in this case. So the object is 55 meters lower than where it started. That's why I see a negative 55 there. It is initially thrown in the upward direction at 14.5 meters per second, so that is a positive value. And the acceleration due to gravity, we know, is negative 9.8 meters per second squared. So this is a quadratic. The easiest thing is to probably just solve it using the quadratic formula. As a matter of fact, that's the only way to solve it. And I get a time of 5.14 seconds for the time that it is going to be in the air for. The second part asks for how fast is it going to be going just before it strikes the ground. We're using the v final squared equals v initial squared plus 2a delta y, where again, delta y is the displacement in the vertical direction. Again, I got to make sure that my signs are correct here. So plugging in the 14.5 meters per second, squaring that, 2 times negative 9.8 times negative 55 meters gives me a value of the velocity final squared is 1288. Taking the square root of that gives me a final velocity of 35.9 meters per second. Although some of you may say, well, Mr. Leffering, it needs to be negative. And to be consistent with the signs, it is going in the downward direction, so a negative sign needs to be included here. I hope that this helps you. Thank you very much for watching.